Today is an exciting day for mathematicians at the University of Chicago. They have received a unique and fascinating gift with a complex background, a Gambot sculpture. Some inventions challenge everything we think we know about science, bending reality in ways that raise more questions than answers. From machines that seem to defy gravity to objects that appear to manipulate time and space, these mind-blowing discoveries push the limits of what's possible. What if the impossible wasn't just an idea but something real, created by human hands? Let's explore some incredible inventions that seem to go against the laws of physics. Imagine someone dipping their bare hand into a pot of molten lead and pulling it out unharmed. It sounds impossible, right? But this is actually possible due to an interesting physics phenomenon called the Leidenfrost effect. While molten lead is extremely hot, it melts at 327.5 degrees Celsius, much cooler than molten iron or steel. However, it's still hot enough to cause serious burns instantly. The secret to doing this safely lies in something very simple: water. If someone wets their hand before dipping it into the molten lead, the intense heat quickly turns the water into steam, creating a thin protective layer between the skin and the metal. This acts like an invisible shield, preventing direct contact for a brief moment. The effect was first observed in 1756 by German scientist Johann Gottlob Leidenfrost, who noticed that water droplets would dance and hover above a very hot surface instead of evaporating immediately. This is the same reason water droplets move around on a hot frying pan instead of disappearing instantly. However, this trick is extremely dangerous and should never be attempted at home. The protective steam layer lasts for only a fraction of a second, and any mistake can lead to severe burns. Scientists who demonstrate this effect take extreme precautions and dip their fingers in for less than half a second. The Leidenfrost effect is not just for dramatic demonstrations, it has practical uses in cooling nuclear reactors, improving fire protection gear, and even in medical treatments. What looks like a risky stunt actually reveals nature's clever way of handling extreme heat. For centuries, people have dreamed of creating machines that never stop moving, perpetual motion machines. These machines are designed to keep running forever without losing energy, solving problems related to power and efficiency. The idea is simple but revolutionary. Once started, the machine would never need fuel or external energy to keep going. One of the earliest attempts to build such a machine was in 1618 by Robert Flood, who designed a water screw that was supposed to rotate endlessly by using the same water over and over again. Later, inventors created the Macintosh wheel, which used magnets to keep spinning. Even today, some try to build similar devices using strong magnets, like neodymium magnets, which can keep an object spinning for years. However, no perpetual motion machine has ever worked forever because they violate the fundamental laws of physics. The first law of thermodynamics states that energy cannot be created from nothing, it must come from somewhere. The second law explains that all systems eventually lose energy and break down due to entropy. This means that no matter how well designed a machine is, it will always slow down and stop eventually. For example, the water screw would lose energy through friction, and the Macintosh wheel's magnets would weaken over time. While perpetual motion is a fascinating concept, it remains impossible because it ignores these basic laws of nature. When the Mythbusters team set out to lift a car using a vacuum cleaner, many people doubted them. After all, household vacuums struggle to pick up heavy objects. However, the team knew something important about suction: the power of a vacuum increases when spread over a larger area. A vacuum cleaner works by removing air from an enclosed space, creating an area of low pressure. The surrounding air then pushes down on the surface, creating suction. The stronger the pressure difference and the larger the surface area, the greater the lifting power. The team built 40 custom suction cups, connecting them to a single powerful vacuum. Each cup formed an airtight seal on the car's surface, and when they switched on the vacuum, the combined suction force lifted the car off the ground. This same principle explains why a small suction cup can hold a shampoo bottle in the shower, while larger suction cups can support much heavier weights. Some mathematicians even calculated that, in theory, a person could lift a car using only their lung power if the suction area was large enough. While that may not be practical, vacuum-powered lifting is widely used in industries today, helping move heavy materials without the need for complicated machinery. This method is especially useful for handling delicate objects like glass panels and electronic components, where traditional grips could cause damage. The vacuum car lift experiment proved that even the simplest tools can achieve amazing results when used correctly. Scientists have long dreamed of traveling to distant stars, but our current rockets are far too slow. Even at speeds of 84,000 kilometers per hour, it would take 54,000 years to reach our closest neighboring star system. This is why researchers are exploring the concept of a warp drive, a futuristic technology inspired by science fiction. Instead of moving through space like a regular spacecraft, a warp drive would bend space itself. Imagine a surfer riding a wave, except in this case, the wave is made of compressed space and time. By shrinking space in front of the spacecraft and expanding it behind, a warp drive could create a shortcut, making distant travel much faster. Unlike traditional rockets, this method wouldn't require fuel, it would surf through spacetime instead. While this sounds like pure fantasy, both NASA and Chinese scientists have observed strange movements in special vacuum chambers during experiments. These unexplained results suggest that we may be closer to discovering new forms of propulsion than we thought. If warp drive technology becomes a reality, it could make interstellar travel possible within a human lifetime, bringing planets like Proxima b, potentially similar to Earth, within reach. Though we are still far from building an actual warp drive, early discoveries show that it might not be impossible after all. Now, imagine a toy that always stands upright no matter how you place it. It seems almost magical, but it's actually the result of precise mathematics. This object is called the gombok, a special shape that always returns to its upright position without the help of weights or special materials. In 1995, mathematician Vladimir Arnold wondered if such an object could exist. The challenge puzzled experts for years until Hungarian engineers Peter Várkonyi and Gabor Domokos finally solved it in 2006. The gombok is a completely solid object with no hidden parts. Its ability to always return to the same position comes entirely from its carefully calculated shape. It has exactly one stable point where it naturally rests and one unstable point where it can balance for a moment before tipping over. This design is similar to the shells of Indian star tortoises, which help them flip over if they end up on their backs. Nature, it seems, had figured out the gombok's secret long before humans. Creating a perfect gombok requires extreme precision. Even a tiny mistake of less than 1/10 of a millimeter can ruin its self-righting ability. That's why real gomboks can cost over $1,000. Scientists study the gombok to understand balance and stability, which helps in designing better robots and even studying animal movement. What looks like a simple shape has led to discoveries across multiple fields of science. These mind-bending discoveries remind us that science is full of surprises. From molten lead tricks to vacuum-powered lifts and warp drives, the world of physics continues to amaze us, showing that even the impossible might just be waiting to be understood. Scientists and engineers have often explored ideas that seem impossible, only to discover fascinating principles of physics at work. One such example is the ability to dip hands safely into molten metal. This is possible due to the Leidenfrost effect, where a thin layer of vapor forms between a very hot liquid and a cooler object, briefly preventing burns. Another groundbreaking concept was the M-Drive space thruster, which NASA tested in 2014. It was a copper cone that supposedly generated thrust using microwaves without expelling any material, seemingly violating Newton's third law of motion. This law states that every action has an equal and opposite reaction, just like how pushing the pedals of a bicycle moves it forward. If the M-Drive worked, it would have made space travel much more efficient, eliminating the need for massive fuel tanks. However, further testing by German scientists revealed that the observed thrust was actually caused by interactions between power cables and Earth's magnetic field. While the M-Drive didn't break physics, it highlighted the importance of rigorous scientific testing. Another unusual experiment involved a sailboat with a fan blowing air at its own sail. At first, it seemed like this setup should cancel itself out, but when tested by the Mythbusters team, the boat moved forward. This worked because the air hitting the curved sail bounced off in various directions, with some of it pushing backward. According to Newton's third law, this backward moving air created a forward push, similar to how jet engines work. Though the method was inefficient, it demonstrated how physics can lead to unexpected outcomes. A similar illusion of defying nature was seen at the 2003 Chelsea Garden Show in England, where James Dyson displayed a fountain that appeared to make water flow uphill. People were amazed, wondering if powerful pumps or magnets were involved. In reality, the fountain used a clever design with two sheets of transparent plastic. Pressurized water was pumped upward between them, while a thin layer of water flowed downward on the outside, creating the illusion that all the water was moving against gravity. This showcased how perception can differ from reality, a lesson valuable in both science and engineering. In another surprising experiment, square wheels were tested on a vehicle. Initially, they made the ride extremely bumpy and even damaged the car. However, when each wheel was offset at a specific angle, the ride became surprisingly smooth. This worked because the timing of the wheel's contact with the ground created a continuous rolling motion rather than harsh bumps. This discovery has practical applications, such as designing better robot legs and machinery for rough terrains. One of the most innovative military technologies is one-sided bulletproof glass. Traditional bulletproof glass stops bullets from both directions, but military engineers developed a type that blocks incoming bullets while allowing outgoing ones to pass through. This is achieved through a precise layering system that responds differently depending on the direction of impact. It provides soldiers with both protection and the ability to fire back, significantly improving armored vehicle designs. During World War II, German engineers attempted to solve a combat problem by developing the Krummlauf, a curved barrel attachment for rifles. This allowed soldiers to fire around corners without exposing themselves. The design relied on strategically placed holes to control the explosive gases, guiding bullets through the bend. However, the barrel wore out quickly, and the bullets often broke apart, making it impractical. Today, modern solutions like cameras and pivoting mechanisms allow soldiers to aim around corners without bending bullets. A different kind of engineering marvel is limbo, a spinning top that can keep rotating for over 27 hours. Unlike regular tops, which lose energy due to friction, limbo contains a small motor, motion sensors, and a computer chip that constantly adjusts its balance. This technology is similar to what is used in spacecraft stabilization and camera gimbals. While it doesn't defy physics, it demonstrates how technology can enhance traditional designs to achieve remarkable effects. Another surprising phenomenon is how a motorcycle or even a car can travel across water if moving fast enough. Just like how small stones can skip across a pond, a vehicle moving at high speed interacts with the water's surface in a way that temporarily prevents it from sinking. The spinning tires throw water backward, generating lift similar to a speedboat. However, this is extremely dangerous and requires precise speed and angle control. Finally, scientists are exploring the idea of a space elevator as an alternative to rockets. Instead of using fuel-intensive launches, this structure would consist of a massive cable stretching from Earth to space, allowing cargo and people to be transported in a more efficient way. The challenge lies in finding a material strong enough to support the weight and withstand Earth's movement. While carbon nanotubes were once considered, newer research suggests that diamond nanothreads might be a better option. Some experts believe a space elevator could be possible by 2050, revolutionizing how we access space. These examples show how scientific curiosity and engineering creativity continue to push the limits of what seems possible, often revealing hidden principles that shape the world around us.